start recording. And start recording locally, please. Where is it? Sorry, guys. I don't see it. Okay, no problem. This is hopefully recording, and it is running there for us. Okay, so B will be another name, a reference for A. Let me check this recording again. Yeah. Okay, we're good. Now, now, what if I say, let's see what we can figure out about these pointers. So what if I say cout and just say PTR, show the pointer? What I will see is the address that is pointing, address of memory. So this is from type address of memory that will be pointed to A. And if I want to see the content, be careful, you need to add another asterisk sign so that it converts. Well, this is probably easier way to understand. If I'm defining integer pointer x is equal to address of something y. So now this is, because of this asterisk, because of this, x is a pointer. X is type address. This is my terminology. I'm just trying to give you a hint to remember this. Now, if I add another asterisk, making it's like I'm doing this. It's not in real life, but imagine this is PTR here, had one asterisk here, and another asterisk is being added. So it's like I'm adding two asterisks here. That makes that it is kind of neutralizes pointer, and it becomes value type, a type value again. Becomes type value again. So look at it from this point of view. This is this is nonsense, okay? But just to remember, it makes life far more easier than we don't know this. So if you're defining a pointer, we are using asterisk sign, and if you add another asterisk, so that makes that a pointer. A pointer is type address. It stores address, not the value. And if we add another asterisk to that, which this guy was a pointer, it already had one asterisk here, we're adding another one. It's as if it takes out that, it neutralizes that and brings that from the world of addresses to the world of values again. So just keep that in mind. So if I run this here, we will see the address, we will see the content of the memory that this guy is pointing at. So we will see here, this is going to be A. This is the 10 here, A. Now this is the address of, literally this is the physical address. This is allocated now by the, this is a part of my stack memory. My operating system has allocated this address. If you can really go check this address on my SSD, you will see that this is the in this address, this value is written. So this is what this line shows. We see the address, and then we see the value, because now by adding another asterisk to this pointer, it's like we made that value again. And now here, the last thing, the main thing that we wanted to know. Now, if I define in the value world, in the world of values, I was able to define a reference to a value. Now, in the world of pointers, in the world of addresses, I can't do that by doing this. So integer, this is now a reference to an integer pointer ptr 2. Now let's say this is a new pointer reference, and I'm assigning to that to ptr1. Just compare line 16 to line 10. These are the exact same thing, except that the identity of this part and this part now is pointer. The type is pointer, not the value. That's why it has this, and these are pointers, right? And now, so here, ptr2 becomes another name for ptr1, just a pointer reference that has that is exactly the pointing to the same place that ptr1 is pointing. It's another name for ptr1. And now if I write cout ptr2, and if I write cout, if I write ptr content of ptr2, we will see how different ptr1 and ptr2 are. We will see if they are different or not. Here you see this was the address that allocated for ptr1. It holds the value 10, and this is another name because now this is ptr2. Since ptr2 is literally another name for ptr1, this is the exact same address and value 10. Now, if we say, so this is what we are using in workshop 9. This is a reference, but from pointer type. Now, if I say now content of pointer 2, I want the content of, because I added another asterisk sign here, it makes pointer the value. So I want value be 20, and then so in this line I replaced 10 with 20, and if I say cout ptr1, I did this to ptr2 using ptr2, but this was the same name. If I show ptr1, we will see that ptr1 has also changed to 20, its value, of course. So let me run this. So the address didn't change, and it wasn't supposed to change because the pointer's address, we didn't do anything to the address, but what we did was to the value, and by changing the content that pointer 2 was pointing to 20, and now if we show ptr1, because these are the same thing, the same exact same thing. This changes to 20. Obviously, PTR2, if you check, that will be 20. So yeah, this is what I wanted to just have a short demonstration of this, and make sure we know reference to the pointer or pointer references. Was this okay?
I have a question. Why we use this? Like, I mean, in real practice, like, do you really use this?
Use what? Use reference
Yeah.
pointer references?
Yes.
Yeah, you can. Actually, this comes handy when you want to pass pointers. We have so far, in many applications, we've been passing value references to our functions because we wanted to save work, make it faster. You've seen there is a huge difference when you're passing a value or passing the reference of that value. This is also like this. If you want to send the address of a send the reference of a pointer, it's the exact same thing. Then you don't need to pass the pointer itself. You can pass the reference of that, which is faster and safer. Yeah. Anytime you want to pass a pointer, this is possible to pass a reference of that pointer, not just a pointer. Okay, very good. Now we're going to see some I/O refinement, and I'm still trying to find my local recorder. Okay, no problem. Now here, if I close this and open this example, is a procedure that we can now. I want to show you the logic behind foolproofing things. The logic is that you have to put yourself, you have to think that the user that is going to enter a value can enter anything. They really may not even read your prompt, right? Because so far we knew them who's writing the main is somebody that knows what the program is, or I am writing, like you yourself writing the main. So it was less possible to enter. Like we didn't even think about it. Like what happens if I enter a wrong value? What is not expected? What happens then? So we didn't care, and because nobody was using our programs, it was just ourselves or some friend that knew what the program is. So we didn't think about it. But literally, if you think, users can, when you want something from the user, they can give you anything they like, and this is the programmer's responsibility to make it foolproof, and don't let the user go, and don't accept the things that they are giving to you unless they give the right thing. So today we are going to do this and see how it goes. Before we start, there is in the utils library that is shared with you and everybody has, we have a get int. We have two get int functions, And these getInt functions, if we look at them, one of them returns int, and the input arguments are prompt and an iStream reference, and it returns int. The other one is basically for cascading the input thingy, and in the input argument we are also sending the integer reference to this function, plus the prompt, plus the input, plus the iStream reference. Now, to understand how we can make things foolproof, first we need to know how these things will break. If something doesn't break, no problem, it's robust, go ahead with that. There's no chance of any mistake, and it's fine. But we know that the things that we have, the input and output streams that we have, are susceptible to specific type of errors. And I'm going to show you, I'm going to give you some example now for this, to see how this thing can break first. And we will also take a look at the implementation of utils here. That we need to. So let's see what these two functions do. This function, this one is reusing the getInt. If we use the second one, the second overload is reusing the first one. And in the first one, what we are doing is a temporary int is defined, and then if prompt is present, it shows the prompt, and then it reads the input to num, which is type integer, and then flushes the buffer. It flushes the buffer. It means in my input buffer, in my keyboard buffer, up to 1000 bytes, or if there is any new line, just flush it. And this means basically you're emptying the whatever garbage you have in the memory and in the buffer, sorry, in the keyboard buffer. And why do we do this? Because well, I'll show you. Because if there is another C in here after this, you will read the good data first, but if you don't flush it, the other garbage will be read to the that C in as well. Anyway, we will see that. And then we return the num. So what could possibly go wrong here? Now, if we look at the main, I'm using the second overload, and simply I've defined an integer. I'm passing that to my function. This is the prompt. This is the input stream object, and I'm just going to show what has been entered. Now, let's see what can possibly go wrong. Okay, asking for an integer. Now, as a user, I don't want to give this thing an integer. I want to give this I want to give this thing a string of characters. It didn't even complain. It accepted something. Now it shows you have entered 0. So if I just let's make it a little bit better. You entered, right? So one of the things that can go wrong is that you're looking for an integer, and the user comes and writes some text, and you're reading 0, nothing happened. It's as if you don't pay attention to this, it's as if you have read your thing, everything is good, but then your program will not work. What else? If somebody comes here and instead of integer inputs a floating point, or by mistake, imagine this is you're asking for somebody's age, and instead of putting 28, for instance, by mistake they put 2.8. What happens is, because you're expecting an integer, your cin object goes and takes the 4 bytes that is for the integers and leaves the rest of the floating point type, which is 8 bytes, just throws that to the garbage, and now your age instead of 28 is 2, which is a problem. Or if somebody by mistake, which happens to me all the time, the space, you put in space and then 8, then you read 2 again, which is a mistake. Or what else? What else can you think of? Or just some random characters comes first sometimes when you're typing, and then put 27. This is the age. By mistake, it reads 0 because of those first 2 letters, 2 characters that are not digits, and you entered. So in many ways, we see that now the program that we have is not foolproof. Or look at this. I just come here and press enter, and then enter, and then enter. If I'm a user that I don't read the, if I'm a user that doesn't read the prompts, or just wants to do something and see how things work, trial and error, how this, if they input this, it can go forever. It's never gonna stop, and the program doesn't have a clue what's happening, and this loop can go forever. So there are many ways that my cin can break. And for the in cin object, to some part can detect some of these mistakes, but not all of them. So we have to take care of many of these manually, and today we are going to go through those. So far, I just showed you how things can go wrong with a simple integer entry using cin. Now, let's start working. Let me close this. And now let's make it this thing a little bit foolproof. And here, guys, I cannot code and talk at the same time, so I have to keep a fresh copy of what I'm coding here. I don't know if you've try to explain what you're coding and at the same time do the coding. I don't know, maybe you're multitask, but it's very difficult. Okay, now what if I tell you that this, so here I open the program that has nothing new. It's everything is everything is copied from the previous file, except for this get int that we are going to make foolproof. Before that, let's see now. We saw how this thing can break. Now let me show you the capabilities of cin object that to some extent, not everything can be detected, but to some extent, at least we can know it failed. For instance, if I write now again, enter an integer, enter an integer. I'm asking for an integer, and then cin. I'm gonna read this cin to a. If any of those things that we just saw, instead of integer, if somebody enters text, a character, um, or a symbol, or anything like that, this will be able to be detected. How? You check this in two ways. Let me just copy it from here and then explain. In two ways. In cin, this is if such a thing happens to cin, if such a thing happens to cin, meaning that it was expecting an integer but it received a character, this negation operator overload of cin will become will tell you if that thing is happening. So by checking this, it's by default it's 1, and if things go wrong, that changes to 0. So by checking this now, this will be the state that cin fails. Another member function of this cin object that can do the same thing but in exactly the opposite way is cin fail. If with cin fail, if cin fails, the value of cin fail will be it's a boolean. It returns a boolean. It becomes 1, and if not, it will be 0. So if this, it means it failed, and else this will be else we got the number was good and it didn't fail. Now it's interesting to see when it fails and when it doesn't fail. Maybe it's good to ask you guys when it fail and when it won't fail. Let's make it an interactive thing. Now I'm going to enter, instead of integer, I'm going to enter text. Will this thing fail or not? The question is, will this thing fail or not? If it fails, we will see this text. If not, we will see this text. Yes. So many people are saying yes. Let's really see what happens. Yes, it failed. It's important to know when it fails and when it doesn't fail, because we're going to categorize these and write two different codes for each part of these. If it failed, what should I do if it fails? And what should I do if it doesn't fail? And it just reads something, but it doesn't fail. So in this case, it failed. When it's expecting, thank you. Some people are answering right now after seeing the results, but yeah, that fails. Thank you. If you're expecting an integer and somebody enters text, it fails. Now, I think Do you hear me? You guys hear me?
Yes, I can hear you.
Yeah, something happened. So now, if we run it again, now tell me, will this fail now? Will this fail or not? Go to the poll. Okay. Will this fail or not? It is 1, 2, some text, and then some number again. Go ahead, please answer. If you are there, please answer. The number of people that are saying that this will fail is more than the number of people that are saying it won't. Okay. It won't fail. Now, if I do this, Cin didn't fail. The entered number is 12. So it is like it picked up the integer part of it and treated the rest as garbage because it was expecting int. So Cin is not that smart. Many of you said yes, it will fail, which was the case that I wish. But Cin is not that smart unless you add some smartness to this. So it didn't fail. Somebody entered this instead of an integer, and it took the integer part. C didn't fail, so it didn't fail. And now we have a very good input, regardless of the stupid mistake that the user has made. Now, tell me, what happens now if I enter if I enter this? Will this fail or not? Yeah. Well, still some people said yes, it will fail. Jamila, you said, sorry if I'm pronouncing your name wrong. You said yes. What do you think makes Cin fail if I enter this? Are you there? Okay, it won't fail. It will again take the integer part and will be happy with that. Cin is happy with that, and it didn't fail. Literally the only cases, and if I put anything like space, enter, nothing happens. Tab, enter, nothing happens. It can go forever. It doesn't even know if it fails or doesn't fail. Why? Because Cin ignores a space. If Cin checks the incoming thing is a space, it ignores it, and it is just waiting for me to input a number. Now I input F, and it fails. Now it fails. So not only it doesn't fail, Cin, not only it doesn't fail for some combinations of characters and integers, which it should, but also there is a bigger problem. It doesn't even recognize a space or new line or thinks like that. It doesn't even recognize that there is no way out of this, and user can really play with this thing. Okay. Now, let me show you some more stuff. Some more stuff is here coming. Now, this was part one. It's if it is not okay anytime, just I'm not gonna ask. Just unmute and ask. Now, there is another member function. Cin has three member functions: cin ignore, cin get, and cin get line. Cin ignore we discussed. It just consumes whatever is in the input and makes it empty for the number of characters that you specify. If you don't specify cin ignore just this, it will consume one character and that's it. It's as if you wipe out that character. That's exactly like this. Cin get, on the other hand, will get that character. So whatever you put there, it will go ahead and read one byte of that string, that input string, and we'll put that in the thing that you're assigning it to. Get line, on the other hand, will read all the characters, and you have to specify a size. If you don't specify, actually the default is 1 byte, I guess. But if you have to specify how many bytes you want and then the delimiter, so when it reaches to that maximum size, or before that it sees that delimiter is coming, it will stop. So this is an example with cin.get. Now look at this. I'm just copying and pasting everything here. So here, cout, I'm sending a prompt. I'm reading cin using cin.get, storing that in A, and doing the exact same thing that I was doing up there. Now the difference, just to emphasize, the difference is instead of cin, now I'm reading with cin.get, which is supposed to get characters one by one, get the characters. And the purpose of the programmer from writing this program is to get an integer and store that integer in A. Let's see how it works. Now I'm gonna run this. I'm putting the code here, and this time you're supposed to think about it and tell me what the output will be. Can you write? I think you can write. For this one, I'm not gonna initiate a poll, but please go ahead and write. So the question is, if I input like an integer, and an arbitrary integer, I'm entering 45. What will be the output given this is what I'm going to handle this program? Write in the public chat area and let us know what you think the output will be. It's difficult, probably a difficult question. Four. Manjo says 4. Armando says 4. Close. It's close. Keep going, please. Fran says 45. Keep going, please. No thoughts from other people? Okay, some people say 45. Keep going, please. We want to see at least 2 more answers. Okay, no thoughts. I'm going to input this. The answer is none of these. It's neither 4 nor 45. And the answer is this. The entered character A, what is now, look at this. With this reading, what we read to A, what is stored in A as an integer is 52. And Cin didn't fail, obviously. What? What is 52? Any idea what this 52 is? Think about it. Think about it. And then write in the public chat. I need to repeat, because now we read with cin.get, I read something to an integer, and I prompt says enter an integer, and I entered an integer, but the result is something apparently weird. I input 45, and what is stored in A is 52. What is it? So Manjo says last number 5 and total number 2, maybe. Good guess. Well, actually, Chirag says garbage value. No, it is meaningful. It's not garbage. It's absolutely meaningful. Exactly. Thank you, Armando. It's the ASCII code of 4. People, we said that this cin.get is going to accept 1 character only. And that 1 character is 4. But it's not going to accept it and store it in A as integer, because cin.get only reads characters. When a character is stored in an integer, the result is the ASCII code of that. So now if I show you number 4, where's number 4? Here's number 4. ASCII code in decimal of that 4 is 52 and is stored in A. Now imagine if you're not aware of these problems and you just let user input anything they want. Okay, good job. To show you that this is the ASCII code, now let's oh, I think I know what I'm doing. I refreshed the big blue button by mistake. Yeah, I refreshed that by mistake. I guess you guys are good now. So now let's run it one more time, and I'm gonna input something, an integer. Don't make it that big. An integer. Now, what we know from our past experience, we know that now this get int will only get 5, but since it's a character being stored in an integer, this the thing that will be stored in A will be the ASCII code of 5. Let's see what obviously is 53. 3, right? It comes after 5, comes after 4. So we should see 53 stored in A. And oh, yes, that's right. Crazy, right? Crazy, but very good things to know. At least we're getting to know the logic of how C in works. Now, if I want to show you, I have more things to show you now. We saw how it failed, and now if I comment it, now in part 3, we're gonna see how the rest from the previous output can make things bad. Okay, I guess I shouldn't. I'm not going to comment this. So let this be. And here, I'm copying this. Here, what we do now, look at these 2 blocks. The first block is the same we played with. Now, I'm adding something else here without sending a prompt or anything. We have 2 cin. One cin is with get, and the other cin it comes immediately after that. It's coming immediately after that, and we see the we can see the basically we should see what happens here now. Let me run this. If I run it and input, come on. What happened? Okay, there's nothing wrong here. What? Is this the problem? Guys, I think something happened to my... Why? Why is it not showing anything? Let me copy and paste from here. It won't change anything. Let's get rid of this. And comment this. Keep this, and comment out this one. No, wrong. Oh, very good. Okay, now we have 2 parts. Let's see what happens if I input something like this. 566. 566. 53 now is the ASCII code of 5 stored in the first one, but without me knowing anything, this 66 also came down here and stored 66 now because we are not using getInt, it's cin, and it reads 66 to A again without knowing this. Imagine if you had this code and you were supposed to store 566 in A, but what happened is first we stored 53 in A, and immediately after that we overwrote that with 66. The result is anyways not we want. The solution is after every single reading you have to flush your buffer, because that was something that was remained in the buffer. So I'm just saying cin ignore 1000 words or a new line character here, and let's run it again. So if I input 566, I know that the first cin is not correct, but it will not, because the garbage is removed. Now it waits for me because of this, the second cin. It waits for me to input a number, and finally we're good to go. Now, one more thing, one more susceptibility, and then we will go to the solution. If I comment it out and comment this out. Now we will see if cin works after it fails. How does it fail? We said that all these problems, and what happens when it fails? It basically a flag, fail bit flag, is turned on, and it goes to the fail state. So when in this object, imagine in this object there is one member variable. It's a flag. So that flag, if that flag is in the bad state, it won't work. Now, if you look at this, it wants me to input an integer. I input something wrong. I clear the buffer, and I read this again. I want to use this again. So here, the scenario is in this one, it will fail because I'm going to enter something stupid. And it will say it failed. And here I will flush the buffer, and the expectation is for the second one, it should wait for me to input a value, right? To input a value. So this one failed, but this one should be okay. I input a new value. It will store in A. Life will go on. Everything beautiful. But now let's see if that happens. Oh, please. All right. Now, instead of an integer, I'm going to input a character. The first one failed, and it didn't wait for me to input for the second one. What does it mean? It means when cin fails, it keeps the state. It goes unavailable unless you clear that, which we will see now in the solution. So be careful. If cin or cout failed, which means their flag became bad state, became fail state, they are not usable anymore unless you first go ahead and clear that flag. I hope I haven't confused you so far. Does everything so far? We have so far talked about the problems, not the solutions yet. Are these all problems clear now? Okay, good. Okay. Now, what could be the solution? What could be the solution for all these possible malfunctionings? The first thing is, oh, that was it. And this one and this one. Okay. So now I said that now we are going to complete this getInt to avoid all these problems one by one. First, I'm suggesting, now you saw that sometimes cin fails, sometimes doesn't. For example, when we wanted, it was expecting an integer and we entered character, it failed, which is good. We can just say, we can just write an if statement here to see if it failed or not. If it failed, obviously the input was wrong. But if it didn't fail, that doesn't mean the input was correct, because we saw cases like instead of int, the input was float, but still it accepted, it didn't fail, but the input was wrong. We have to take care of that manually. So what basically I'm going to write here, first of all, not to let the user go away, to stick the user with glue to this, we're gonna say this. Let me just copy the whole thing. I guess we're running out of time. Okay. What I did is, first, I'm putting the user entry in a loop, in a while loop, and I'm not gonna let this user go unless it gives me the proper input. So I'm using while for that. While done is defined as a Boolean variable set to false. While done is not done, I'm reading the input. Okay, reading. That if condition is this, if and else. You remember in here I checked cin, if cin fails. The same thing happens here. If cin fails, this istr is cin. If cin fails, meaning that the user failed to put a proper input. It, instead of integer, it put character, for instance. What I'm going to do is first clear this. What does it do? It clears the error flag that we just talked about. If you don't do this, you're not going to be able to read anything else, no matter how much you clear your buffer. It's the problem is that istr is still in the failed state, and you have to go ahead and clear that. By clearing that, you are clearing that flag, and istr in here cin, for instance, becomes usable again. And then I'm gonna go ahead and wipe out whatever garbage that the user entered, and then show a message. I want to show a message. It was invalid. Give me something good. But this was for the fail case. Crystal clear. If the garbage was so garbage that cin failed, then I'm gonna clear everything and show a message. But if the garbage was somehow garbage, not a garbage that could fail my cin, like inputting a double, for instance, or the inputting number plus some meaningless character or a space or something, just a mistake, you're typing, it can happen, and then the rest of the integers, I'm gonna detect that manually. So after this is why in else I didn't say done is true, because even in the else case, which is not failure of cin, there is a possibility of garbage input. What kind of garbage inputs? Because of the practice that we did not, things that I've written here are clear for you. For example, a floating point or a character after some int. Basically, what we are looking for is this pattern. If you look, if the user entered int and then pressed enter, that is the correct input. Other than that, if the user puts some number and then some character which is not enter, that's for sure not a correct input. How do we do this? We can use get now. Cin get. Why? Because get reads the character. Now, look at this part. I'm already done. If somebody entered this, if somebody, for instance, entered 12 or 6, if somebody entered this 12 part is already done, is already taken out, and is already put in num in here. What is remaining here is the rest of this garbage. So 12 is taken care of, and what the get will see here, get will see istr get will see here is this thing. And from this, again, based on the experience, based on the practice we had, what this will see is the O part, because get only reads one character. When it reads O, it consumes that. 6 remains as a garbage. O comes down here and it says, is this character of mine a new line character? If that's the case, it means we put enter, which is good. But if it is not a new line, that means something went wrong. Now, if that thing, that character that it reads, and character here, see, it's a character. It's a character. New character is a character. If that character is equal to this floating point, now this is a very smart way of showing a very smart and meaningful message. Now, user, I know you by mistake or on purpose entered a floating point. Go ahead and correct it. Else, if it is anything else other than new line, I'm going to show that it's not a proper entry. Like this new character, we will detect that new character and say that this is not a proper entry. We will wipe out the buffer, we'll clean it, and if none of these happened, then we're good to go. Then it's true. Okay, very good. Now I make done true so that I get out of this while loop, right? So now let's run this. Okay, I'm gonna put some garbage first. Oh, sorry, we have to change this here. In the main, sorry, it is this, and now here, just easy, right? I'm using this get int of mine that I have in utils, and let's see what happens. Now it's calling this one is calling the second overload version, which calls the first function. First, let's enter some garbage. It detects the garbage, invalid input. Please enter again. This is this if part. Invalid input, please enter again, because it detected that it's not text. Now, I'm inputting this by mistake. by mistake. It's gonna say now character. This is now this part. It came here. It was else because it wasn't garbage. It didn't fail. It came to else, and here detected, read that character of mine. This here and character. It read it. It wasn't equal to floating point, but it was something else. So it detected and says, and now says it's not a, this character is not a proper entry. Please retry. And now I'm going to enter something with decimal point. Now it's going to say floating point number not acceptable. Give me a good value. And to give it a good value, I'm going to give it a good value. This way, in this solution now, we basically distinguished between what can fail CIN and what will not fail CIN, but is still a garbage or an input that is mistakenly entered in this loop. Next is we will do something even better. We still have 10 minutes time. I'll try to be quick. Does this make sense to everybody? If not, please ask your question. Okay, good. Next is what? Next is if we can. Let me just quickly go over this, but this is easy. Next thing is somebody may argue that not only you need to take care of this malfunctions, but also you also need to make sure that the input is in a range, is in a range of acceptable range. It's in the acceptable range. So to do that, this one is easy. Let's just quickly take a look, and we will be done. For that, you need to show them the basically the input and the range that we are looking for. So this will become, please. Okay, very good. So we can write a new overload. In this overload, we can give them the maximum and minimum, and we can ask them to input this because we already have this very good foolproof enter entry check. We can use this and simply say, okay, now I have this, and what I'm going to do is just going to do this in utils.cpp. I'm gonna do this here. I'm gonna say, okay, go ahead. If there is max or mean, go ahead, read that value using that foolproof thing. Now it gives me a good number. What I need to do is just check if it is in the range or not. That's it. And by doing that, we will be good. Here, it will say, give me a number. Give me a number between -6 and 8. I'm going to give 70. Not going to accept. I'm going to give garbage. Now that foolproof thingy will come into play. I'm going to give floating point. It's not going to accept. 3R5. It's not going to accept. Finally, give it 5. And that's what I want. So in this one, we also added maximum and minimum. One more thing is remaining, which is very good to know. And after that, your quiz will start. So I'm also going to show this to you. What happens if somebody just inputs, says just enter, press enter and leaves, or puts a space. We saw that enter and space are not detectable by cin. They are ignored. So to catch these problems, we can do this. We should use probably a new thing to you, or maybe you know. We should check what is entered first without consuming that thing. What is consuming? Consuming is when you for instance get cin.get reads the value, and that value doesn't exist there anymore, right? It goes completely out of scope after that thing is read. But we want to, if you want to check what is entered but don't consume that, still keep that in buffer, we use peek, P-E-E-K, and for that I'm just entering this piece of code before even we start reading. I'm adding this piece of code here, and this makes it expect. Now it says if something is entered, don't read and don't consume that, because we have job to do with that. Don't consume that, but just go check if that's a new line, or that's a tab, or that's a space. Then don't let user go away. Say that this is wrong and ask for the new number. The rest is just the same. So here, if I run this, let me see. Yeah, if I run this, if it runs, yes. Now, in the previous examples, you saw that if I pressed enter, nothing happened and the loop could go forever. But here, if I press enter, it knows input an integer instead of new line or tab. Well, now I'm entering tab. It detected space. It detected. There's no way that user can go away unless they input something meaningful, and this ends here. So I guess this was discussion about the foolproofing to the bone. Couple of things to summarize. cin and cout fail. cin doesn't fail sometimes, but that doesn't mean the input is good. You have to expect, you have to take care of any garbage, and think about what can be entered that you are not taking care of. And for cin, cignore, cget, and cgetLine are the input. For cout, also in the notes, there is this part. In the notes for cout, we have two other versions that are exactly identical to cout, but are runaways. If cout fails, at least you should be able to show the error message. Imagine if cout fails, you will not be able to show anything. So in this case, we use CER, and CER, I'm writing here, CER and CLog. These are identical to cout, exact same thing. Just in case this fails, you can use these guys. Other than that, we have covered everything that is in the notes for the input output. Go ahead and try to. It's a bit difficult because you have to think what can possibly go wrong, and then write a code for that. But this is a systematic way of preventing any garbage input. That's it for today. On Thursday, we will start some part of this remain that I couldn't explain. One program we will see, and then we will see templates. We will see templates. Yeah, if there is any question, I'll be more than happy to answer. Otherwise, your quiz will start at 4 o'clock. Thank you, Armando. You too.
I have questions. So after the quiz, can I text you through the MS Team?
Yes, of course. Yeah.
Thank
Yeah,
you.
yeah, go ahead. No problem. Thank you, Sebastian. You too. Have a great day. Okay, thanks everybody. We'll see you on Thursday. Good luck with your quiz. Quiz is just concept questions, easy peasy. Just concentrate on answering and you'll be good at it. Great. I'm happy. Thank you, Trent, for your feedback.